We're going to talk today about work that's been going on, truly some interdisciplinary work, and hopefully we can end on a higher note that we're trying to avoid conflict. We're working, it's based on work that Sherman and I have been doing over the last 30 years related to the resources of the Nile Basin, and the talk today is going to try to show where we move from a resource-based allocation to a economic benefit-based allocation, and we think that there is some reduction in conflict that can happen as we move that way. So the purpose of the study is to look at how a new Nile Basin agreement may have an impact on the economy of Egypt. And to do that, we're going to use three analytical tools: a hydrologic model of the Nile, which is a model that would be used to project the flows entering the Hydropower Dam; an operational model of the water system of Egypt that includes the demand for irrigation and the power produced at the Hydropower Dam and the other barrages; and then finally an economy-wide dynamic computable general equilibrium model that takes directly into its formulation and operation the hydropower and irrigation from the other models. To give you a context for the Nile and Egypt, for those of you who may not be aware, the Nile flows from equatorial lakes, and it's in two parts. It's the White Nile that flows from Lake Victoria onward and joins the Blue Nile at Khartoum. And then further down, as we move by in northern Sudan, there is the IFPRI River that joins and forms the final Nile on its way to Egypt. And the significant part of this is that 59% of the flow arriving at Egypt comes from the Blue Nile, and another 13% from IFPRI, and some from the Sobat. So 85% of the water that arrives at the Hydropower Dam originates on the Ethiopian plateau. So there is none of the Nile because of rainfall, there is no water generated in Egypt. It comes from upstream. And the other factor of the Nile is that it comes in a very strong flood season. It arrives over 3 months as the summer rains hit the Ethiopian plains. And then the White Nile, which comes from Lake Victoria, spreads through the wetlands of southern Sudan, and you get an even distribution over the year, and then you have the spike of the Blue and IFPRI waters. So this comes as a big flood that, as we know, entering Egypt, which varied from year to year, but it arrives, which is the bar chart there, in the August, September, and October, and it is only available primarily for winter crops in the natural setting. And the issue is we would like to take this water to be able to spread it out and grow 2 crops over the year, and particularly to use it for summer crops, which are more valuable. So that's the reason the Hydropower Dam was built. And in 1959 was the first Nile Waters Agreement between Sudan and Egypt. And as part of that, Sudan was allocated 18.5 units of the 84 units of flow that enter the Nile at Egypt. Therefore, 65.5 went to Egypt. But when you store that water in the large dam at Aswan, there is an evaporation of 2 meters every year from that top. So you lose on average about 10 units, or almost 20% of the water is lost to evaporation. But what you do is convert that very variable line that you see there, that dark line, which is the history of annual flows in the 20th century, to the dark dashed line, which is the guaranteed release from the Aswan Dam, or safe yield from the dam. And so you lose 10 units, but then you go from a very highly variable system that brought you floods and droughts to a system of a constant release. And in the 40 years since the dam has closed, it has produced that amount or more over that period. So since it's been built, and during this period, In the early part of the century, Sherman Robinson and I were involved in a project to look at the value of the High Aswan Dam and what did it mean to Egypt of taking that variability out of the flow. And there are significant economic benefits to the High Aswan Dam to the Egyptian economy, straight up in an expected value area, but also in, if you take risk value into it, it greatly increases in what it did for the economic growth. So given that, we wanted to look at what did it mean for the economy of Egypt if the type of developments that would take place as a result of new Nile development and sharing of the Nile waters. So what we're focusing on in this presentation here is the development on the Blue Nile of major hydropower reservoirs. These hydropower reservoirs are generally non-consumptive. They would hold the water at a high level to be released to make hydropower, but there is some irrigation planned as part of these projects, so there are some consumptive uses, but the primary issue here is a changing of the regime of the flows to Egypt within the year, as well as what we call episodic events where these dams have to be filled, and the amount of water stored in those dams is equivalent to 2 years of the Blue Nile flow. So we can have significant impacts of this development in terms of timing. So what we put together was a scenario to look at what is the worst case situation that Egypt may face under a development. So we took a historical 50-year period of the record, which is that outlined in red on the screen there. And then we looked at what is the worst 5-year drought on record from the last century. And then we imposed that drought at different decades, different times in the future on that record so that we can see if timing or transition matters. We then said that Ethiopia would enter on a very rapid development of its irrigation in the Blue Nile, so it would be completed by 2020, and that there would be a rapid completion of all the hydropower dams with rapid filling. And then finally, if that wasn't strong enough, we then looked at climate change scenarios up to 2050, and we took the driest one. We just want to point out that equally unlikely is increased flows in the Blue Nile, so that the climate models are saying there could be increases and decreases of the flow in the Nile by 2050, so we took the driest one. So given that scenario, what we see are these future scenarios of inflow to the High Aswan Dam. So the highest line there, the dashed black line, is what the historical sequence would be for 53 years with none of these other impacts. We then look at if a drought was in 2010, that is the light blue, the dark blue line. And then we look at if it was in 2020, the drought period came in 2020, and then if the worst case end is climate change, and then if the drought is in 2020 with maximum use. And what this curve shows is some very dramatic impacts that can occur. With the flows in the 20s period being somewhere close to 20, where the average coming in to this period be something around 55. So the releases, that's a significant resource impact over a couple years during that period. So we want to look at what that means. So this is the results of the High Aswan Dam model, which shows that there is some dampening when you go and look at what happens to lake levels, because the High Aswan Dam can hold 2 years of flow of the Nile River. So it acts to dampen these shocks that are coming in. Even with that dampening of the shocks, here is what would happen to hydropower production. And just to highlight it, there are, in the 20s, the light blue, there are 2 periods where there's 3 years we get about 50% of the energy generation from the dam than we would have in historic conditions. So dramatic reduction in hydropower entering the system at that period. Now, food security, the way the Aswan Dam is operated, it is operated to provide the maximum amount of agricultural production first, and then hydropower is generated when the releases for agriculture and irrigation are needed. And so here we see that in the period of the 20s again, we can see significant, and what this curve shows is the reduction in irrigation water supply. So there are 2 years, 1 year apart, where we get about 35% reduction in irrigation supply water. And then in between 1 year of about 10. So a significant hit for a 3-year period on irrigation supply. So these are major resource or engineering impacts. And so what we want to do, and this is the work led by Dr. Robinson, is to examine the economy-wide impacts of these changes in hydropower and irrigation supply via the CGE model. And the computable general equilibrium model is applied widely to look at policy analysis. It's good for looking at changes, for looking at shocks to the economy, and other changes that may happen simultaneously over the economy. This is a quick schematic showing the form of this model, which is part of the standard IFPRI model. And when we look at the factors, we have institutions in the model. We have the households, both rural and urban, by quintiles, the government, rest of the world, and then the factors of production come directly, the water, and then the land, which is a really important issue in Egypt, the land constraint that comes in to the system. So as we run the model, we get some interesting outputs. The first thing we want to show you in this slide is a key historical trend on the top, and that is the percent of total GDP that is coming from the agricultural sector. And this upper graph is a picture of since the High Aswan Dam started to release irrigation water. And one of the things you notice is in the 70s, a very rapid drop from 30% to about 20%. And that can be attributed to the very inexpensive and large supply of hydroelectric power energy that came from the High Aswan Dam, allowing for industrialization with high energy sectors. And then you see it leveling off and continuing. And then the model on the bottom is, what is the modeling saying now? Is we're seeing a continued, as the economy grows, a continued structural change in Egypt with, by about 2050, the ag sector going from 14% now to about 5 or 6%. Likewise, one of the things that's interesting is this is a combination of history and planning, is that when the High Aswan Dam came online and generated electricity, it produced 70% of the total electricity used and demanded in Egypt. And over time, as the economy and the population grew, and there was a greater demand for electricity, we couldn't add to the High Aswan Dam. It had been at its maximum capacity, and we can't additionally add. Other thermal and other methods have come on for energy generation. And so the role of the High Aswan Dam has continued to decrease. So right now that it is about 10% of total energy generation, and the plans for thermal and renewable generation in Egypt show by about 2050 it will be about 2% of the energy generation, electricity generation in Egypt. So these two factors are going on, a structural change in the economy with continued growth of the other sectors. So given that, what we were able to do with the model is to look at, under the dynamic growth of the economy, what is the impact of reduced High Aswan Dam releases on the economy of Egypt? So if we look, the bottom line there is what would happen now in the current structure. And so if we were to have the kind of reductions of flow that we saw down to 20, or about almost a 60% increase in a year of flows into the Nile, it then gets dampened through the Aswan Dam and then dampened through an economy. We see about a 6% drop in GDP in 2010. As we move to 2030, it drops to about 3, and then when we're out there at about in the 2040s, it's at about 1%. So the structural change making the economy of Egypt less dependent on the hydropower from the Aswan Dam, and GDP being a smaller and smaller portion of the economy, greatly dampens the impact of the Nile waters themselves. So what does this mean? If we look at the unmitigated economic impacts that could happen from this worst case scenario that we can't even put a probability to. But in 2020s, while the economy still has not fully transitioned to be out of agricultural being an important sector, and the Hydropower Dam is still a significant area, we lose about 2.5% of total energy for 3 years.
When you have 2 more minutes.
Okay.
Yeah.
We have in this 2 years of 35% loss of irrigation supply, we end up with 2 years of 1.5 GDP loss and 1 year of 0.5% of GDP loss. So these type of economic variations were common in Egypt and were observed in the pre-high dam times. If you saw before that variation of the Nile flow coming in, we would have great variation from year to year in the amount of flow, and you would have flood damages, which we have no more, as well as low flows. These same water impacts that we talked about would be even more reduced if this drought period happens in 2040. So we have no idea when a drought may come. Inshallah, it won't come in the next 100 years. But if it does come later, the further it comes, when the economy is less dependent on the Nile, the less the impact is. So what can we do to mitigate these impacts? So one of the things that Egypt can do unilaterally is irrigation management improvement. And one of the things with this little graph on the right is to show that what's very clear is Egypt uses a lot of water on their crops because of the economics and the water management scheme. So farmers will use a lot of water. The last point there, A, on the production curve there, the yield curve. So we can reduce the amount of water and not have as a very great loss in yield. So as well as bringing in different management techniques, they can do that. One could look at alternative crop selections, looking at more high-valued crops and importing other crops, looking at a change that would happen through economic structure of the ag economy. The other thing we can do is, if we are worried about drought, one of the important parts of the Hydropower Dam is it has about 1/3 of its storage for flood control in case a large flood comes in from the Nile. If we're worried about drought, we can reduce some of that flood control protection, which increases in a small way a risk of flooding, but would allow us to have more water in the dam to dampen or buffer any of these types of shocks. So Egypt can do that on its own without. However, with regional collaboration, there can be a lot of things that can happen to do this. A new Nile Basin Agreement will have water sharing and will have rules when there are droughts that upstream countries will have to curtail. Ethiopia could refrain from filling dams during the drought period, which we do in the worst case scenario. Sudan and Ethiopia could reduce irrigation consumption during the drought as part of a trilateral activity or part of the way the Nile Basin Agreement would go. The African regional power pools that are coming into planning might be able to make up the shortfall in energy generation as well. There can be increased and secure agricultural imports that may be backed up by different organizations or countries or regions to protect Egypt from those shortages. And finally, one of the things that we're continuing to look at is the long-term importing of low-cost electricity from Ethiopia. If Ethiopia develops these dams, they cannot absorb that energy right now. The economy isn't growing fast enough or electrified enough. So they want to put it on the power pool. They could make an agreement to supply that energy to Egypt, so we would see a similar boost like we saw after the Hydropower Dam, and that would increase the rate of structural change, making Egypt less vulnerable. So it leads us to our conclusion that long-term economic impacts of upstream Nile development are significant, especially in the early decades, but decrease over time. Even this worst-case scenario, while painful, is manageable, and particularly it can be managed with cooperation. Egypt will benefit if it receives low-cost electricity produced by Nile hydropower throughout the basin. Egypt would benefit in times of drought through a regional management of the Nile flows. So if this other infrastructure is in place and there are agreements for water management, a drought that would have come anyways before the development and Egypt would have felt its impact can now be mitigated through cooperation. And finally, many of Egypt's economic impacts can be greatly reduced by regional cooperation and the sharing of benefits and a cooperation upstream and downstream of all countries. So we think that there is a potential for conflict as we look at it on the surface, with upstream development seems a threat. As we look at some of the results of the models, there seems to be maybe a chance to avoid conflict through cooperation and thinking ahead of some of these activities. So thank you very much.